Good evening, class. This is Mr. Pollock here. We're just going to review some of the concepts we worked on today in class. For those of you who need a little bit extra practice, we're going to go over the notes again from today in class. If you were not in class today, please feel free to watch this video, take some notes on it, and work on the practice problems throughout the lesson. So after today's lesson, we're going to be able to write equations in slope-intercept form from a graph. We're also going to be able to graph an equation in the form of slope-intercept form on a coordinate plane. Okay, here we have some of our notes. The y is always by itself. Y is the dependent variable and always remains y. It'll never change. It needs to be y by itself. The m represents the slope. We want to keep the slope as an improper fraction. The m is replaced with the value of the slope. The x is always attached to the slope. The x is the independent variable and always will remain x. The b represents the y-intercept, and the b is the starting point when we go to graph this. Okay, pause this video, take a few moments to write these steps down. We're going to be using these for the next couple problems. Okay, for example, we have this problem here. We're going to go on, we're going to be working with graphing this. Again, we need to start with our starting point, which is this value here. So we're going to come up to, we're going to plot that point. Come over here, identify the slope, which is right here. We're going to do a rise of 2, a run of 1. Now, I'm using my mouse, but you guys are going to be using a ruler, so my line's not going to be as straight as yours. We're going to connect those, and you're going to make it into a line. Okay, next one, we're going to start with our starting point, which is a -1, so we're going to come down 1. Make sure you always take that negative sign with it. We're going to look over at the number attached to x as our slope, so we're going to go up 1 over 2. We're going to plot a point there. We're going to connect those and make a line out of them. And again, we need to put an arrow on the ends of our lines to make it a line instead of a line segment. And again, yours is going to look a lot more straight than mine. However, I'm using the mouse cursor, and you should be using a ruler on your paper. Okay, and if you want to take a moment, pause this video, you can practice these two problems. Look at the hint. What is different about number 1 and number 2? And how do you think that graph is going to be affected by that difference? Again, take a moment, pause the video, and work on these two problems. Okay, you can pause the video after you watch this and write these notes down in your notebook. Okay, we're going to write the equation from the line here. This time we're going to start with the starting point, which is the y-intercept. So we have a y-intercept of plus 4. We need to find our slope, so we're going to pick 2 points. I like this point right here and this point right here. We went down 1 over 2, so we went down 1, -1, over 2, so -1/2. Remember, we always have to put our x in here, and it's going to be y is equal to that. Okay, for here, we're going to start with our starting point again. Our starting point's right here, it's a +1. We're going to look for 2 nice points. There's a nice point here and a nice point up here. We went up 1 over 1, 2, 3, 4. Up 1 over 4, so 1/4 x. And remember, y is going to be equal to all of that. Good job. Okay, you can pause the video. Go ahead, take a moment, work on these two problems. Why do I need to know this? We need to know this because there are many, many different real-world applications of using slopes and finding the slopes and finding the y-intercepts that we need to know in order to be able to have several different jobs. Architecture is one. Designing roller coasters, designing blueprints. For example, a handicap ramp. That's not designed randomly. That slope is strategically picked in order to make it the most effective ramp possible. Stock markets, when you're projecting data over a given point in time, these people are working with slopes because a slope is a rate of change. It's the rate of change of your money over a given time. Okay, we also completed this problem in class. I want you to take this this graph and find the equation for it. You can write it on the sticky note or put it in your notebook. We wrote it on the sticky note and put it on the door on our way out the door today. Okay, again, here's the homework assignment. You already are watching the quick recap of today's lesson. I also want you to complete this Google Docs assignment that's found on my teacher's page. If you have any questions, please feel free to email me. I will respond rather quickly to your emails. If not, have a great evening, and I look forward to seeing you tomorrow in class.